Welcome to Section 4.1, Detours and Midpoints. Our objective is to use detours and proofs and to apply the midpoint formula. Now our homework is going to be split between 2 days. For our first day, our homework is going to be on page 73 to 75, numbers 2, 4, 9, 10, and 12. For day 2, we're going to be working on numbers 3, 11, 13, 14, and 16. Detour proofs are proofs that require more than one pair of congruent triangles. So in other words, we're going to be proving triangles congruent in order to take apart their pieces and prove other triangles congruent. So here's a general procedure of what's going to happen. The first thing we have to do is determine which triangles need to be congruent in order to reach your conclusion. So keep the end in mind. Step 2. Attempt to prove these triangles congruent, if possible. If not possible, that's where the detour aspect comes into play, which is steps 3 through 5. You're going to identify which triangles can be proved using your given statements. You're going to use CP/CTC to prove necessary pieces congruent that will be helpful in reaching your conclusion. You're going to prove the necessary triangles congruent and use CP/CTC to reach your conclusion if need be. The next part of this section talks about the midpoint formula. The midpoint is used to find the middle of a line on a coordinate plane. It's found using the averages of the x's and the averages of the y's. Or in other words, add up the x's and divide it by 2, add up the y's and divide it by 2. Alright, so let's do some examples. We're going to cover 2 algebraic examples and 2 proof examples. So here's our first example. If A is at 3, 5, and B is at 7, negative 9, let's find the midpoint of AB. So applying our midpoint formula, let's add up the x's and cut it in half, comma, add up the y's, cut them in half. It is a midpoint, and points have both x and y coordinates. So here we go. We would get 10 over 2, which is going to be 5, and negative 4 over 2, which is negative 2. Our midpoint of AB is at the point 5, comma, negative 2. Next, let's say the midpoint of AB is C. If A is 5, negative 2, find the coordinate of B. In a picture, this is what this is going to look like. Here's our segment AB, and C is going to be our midpoint. So they give us the end in mind, that C is going to be at the point 3, comma 2. And they give us the other endpoint, which is at 5, negative 2. They want us to find out what B is. Now, we have 2 ways of doing this. The first way is going to be the algebraic way. We add up the x's from our endpoints, chop it in half, and that gives us the x of the midpoint. When I get rid of that 2 on the bottom, we end up with 5 plus x equals 6, and when I subtract 5 to both sides, my x is going to equal 1. Now to solve for the y. When we add up the y's of our endpoints and divide it by 2, it gives us the y of the midpoint. Again, let's get rid of that 2 on the bottom. And negative 2 plus y is equal to 4, and when I add 2 to both sides, my y is going to be equal to 6. My midpoint here is going to be at the point 1, comma 6. Now, is there an easier way? Absolutely. I'm going to erase these points here. And we're actually going to do this a visual way. Now, I like to put my x's on top and my y's on the bottom. And I'm going to change this and do this in another color here. Let's do it in purple. Now, if the coordinates for my x was at 5, negative 2, and the coordinates for C are at 3, 2. Thinking about what a midpoint is, it's halfway between the endpoints. It means that it's an equidistance between my endpoints, which means an equidistance between my x part of my coordinate. And to get from 5 to my midpoint, 3, I went down by 2. I would need to do the same thing here again. Going down by 2, it leaves me at 1. For my y's, it's at the halfway point as well. And from my endpoint to my midpoint, I went up by 4. So let's go up by 4 again, and that brings us to 6. My endpoint for point B, again, is at the point 1, 6, algebraically and more visually. So here we go. We start with one of our two proofs. So let's make a statement and reason column. And let's go ahead and start doing this. We're going to start off with PQ bisects YZ. Q is the midpoint of WX. Angle Y is congruent to angle Z. And WZ is congruent to XY. Those are going to be my given statements. Let's put in our markings. We have angle Y is congruent to angle Z. WZ is congruent to YX. Then I have some keywords here. My keywords is that PQ is bisecting YZ, and that Q is going to be the midpoint of WX. So I got a couple keywords floating around there. I'm trying to prove, I'm going to put this in a different color, that angle WQP is congruent to angle XQP. So that's what I'm going to try and prove in the end. And when I look at that, I see that it's going to be a CP-CTC step for these two triangles here. We got to work our way down and get that. Well, right off the bat here, I'm going to use this given statement that PQ bisects YZ, and I'm going to say that these two pieces right here are going to be congruent. That ZP is congruent to YP, definition of a bisector. And I have a triangle congruency here. Triangle WZP is congruent to triangle XYP by side angle sine. My next thing that I want to ask myself is what pieces of this triangle would be helpful in order to prove these triangles are congruent. And what I could say here is that WP being congruent to PX would definitely be helpful. I'm going to put in those tick marks right here. Now, what I also see here is that I have a reflexive line. I can say that PQ is congruent to PQ by reflexive. I'm running out of tick marks. I can either draw 4 lines or I can draw something like an X. Next, I had a key word here. It was a key word from my given. Stated that Q is the midpoint. Let's go ahead and let's state that WQ is congruent to QX. The reason was definition of a midpoint. I'm going to put in my tick marks. I'm going to put in circles. Tick marks are just two of the same symbols over congruent pieces. Now, looking at my triangles here, I see that I have congruent triangles by side, side, side. If you saw things differently, perhaps if sides then angles, you can have a different way of proving your triangle congruent. Now, I'm starting to run out of room here, so I'm going to bring it over here. Here's my statement, here's my reason. We're at our triangle congruency step. I'm going to say that triangle WPQ is going to be congruent to triangle XPQ. For me, it was going to be by side, side, side. So my CP-CTC step is going to be that angle WQP is congruent to angle XQP. The reason? CP-CTC. So we took a detour. We didn't have a direct path to get where we wanted to. So we had to prove other triangles congruent, take some pieces that were helpful in order to prove our other triangles congruent to get our end conclusion. Now here's one for you to try. It's right up here. We are given circle O and that angle B is congruent to angle C. We want to prove that AO bisects BC. So let's see what you can do. Give it a try. Alright, so here I go. Statement and reasons. We have circle O. We have angle B is congruent to angle C, and those are our givens. So here we go. Let's see what we can do. Well, the first thing that I see that I can do right here is I can do an if angles then sides. I can end up saying that AB is congruent to AC. If angles, then sides. And I throw in my tick marks. And I think to myself, oh, this is easy. I can do reflexive, but it says angle side side. The angle is not going to be smashed between my two sides, so I got to back off a little bit. Now, can I use HL? Absolutely not. I don't have right triangles. So now we got to take a step back and we got to think of something else. Well, the one thing I can think of here is I can draw in some auxiliary lines. So I'm going to start with that. I'm going to draw OB and I'm going to draw OC. Draw OB and OC, auxiliary. Now, those auxiliary lines are also radii. I can say that OB is congruent to OC because all radii are congruent. And now, when I look at these big triangles, what I'm going to end up having here is I'm going to have a reflexive side right here, OA, is congruent to OA reflexive. And those big triangles, triangle OAB is congruent to triangle OAC by side, side, side. Now, I still want to get to bisecting that BC, so I got to think, what's going to be helpful here? So let's take apart a piece here. What would be helpful? Well, one thing I could think of that would be helpful is if I said that these two angles up here on the top are going to be congruent. I could go ahead and say that angle BAO is congruent to angle CAO by CPCTC. Now, what I see here is this triangle right here now has an angle, a side, and another angle. And this triangle right here, I have an angle, a side, and another angle. Now I'm all good to start saying that triangle BAE is congruent to triangle CAE by angle side angle. Now, my next step, to prove that AO is bisecting BC, I need to have those congruent pieces. So let's go ahead. Here's going to be my congruency. BE is congruent to CE by CPCTC. Now, if I see that I have a segment that's dividing a segment into two congruent segments, which it is, I know that that segment was a bisector. My proof step, AO bisects BC. If a segment divides a segment into two congruent segments, it bisects. And we're all set. So here is our homework answers. So our homework once again was split between 2 days. For day 1, we had problems 2, 4, 9, 10, and 12. For day 2, we had problems 3, 11, 13, 14, and 16. Please take your time and work through these slowly. And if you have any questions, please make sure you ask. As always, have a good one.